You probably thought we got away from doing proofs because we were having so much fun, you know, figuring out and using algebra with these parallelograms. And now it's proof time. I know you're just so happy. I can hear you screaming from your house. All right, example 4, we're using properties of parallelograms in a proof. And actually what we're doing is it looks like we're proving theorem 6-2-2, which was the one that shows opposite angles are in a parallelogram are congruent, is what it looks like. So we're actually proving that theorem, so you can't use that theorem to prove itself. It's kind of like defining a term with the term itself. I know people do that, but you shouldn't. There should be some other words to use to describe that. So let's go ahead and jump in. We're going to do a 2-column proof as the instructions tell us. We're going to do statements and reason. And you guys are always hear from me. You should always get the first step correct and the last step correct, right? And the first step is always put your given there. So we know that ABCD is a parallelogram, okay, and we know that because that is given. All right, awesome. So how do we get this thing started? All right, we're going to use the other theorems. We're just not going to use theorem 6-2-2 to prove itself, okay? So one of the things that we do need to know, and you can see from the figure that, you know, there's lots of, we've got diagonals going on there. We just got a lot going on, but it is marked up as a parallelogram. So the first thing where I think we should get started is to talk about some segments. All right. So the segments, I had to look at my book really quick. The segments that we want to tackle are going to be this AB. So segment AB is going to end up being congruent to segment CD. And then segment BC is going to be congruent to AD. Okay? So the reason why we can say that is because we know the figure is a parallelogram. We can use that very first one. If we got a parallelogram, then the opposite sides are congruent. Okay, so you can use that symbolism that we used before. Okay, so as you go along, if you want to, you can mark it up. Sometimes me marking on my figure really gives me, you know, some really, really good ideas about, well, where am I going to go next? What am I going to do? Okay, so let's take a look. And the cool thing is, I'm going to try and put some dashed lines here so you can kind of see what's going on. And we're going to split this because the other diagonal is a little bit confusing. So we've got this triangle basically, okay, that's formed from BD, that diagonal, and then you've got, if I take the other one out, I'm not going to put the AC diagonal in there. But do you see you've got 2 triangles here? You got a triangle here and you got a triangle here. And you already know that this side and this side are equal, this side and this side are equal. So it really kind of makes sense to go, okay, I'm jumping in. I'm going to go ahead and say that BD is congruent to itself because of the reflexive property. Okay? So that's exactly right. You can do that. Now, because you've done that, then you can now say that those 2 triangles are congruent to each other because of a previous strategy. We had 5 that you could do. So the triangle formed by BAD is going to be congruent to DCB. And do you remember why? Because you know that you've got 3 sides in one triangle are congruent to 3 sides in another triangle. That's side, side, side. So that's what we were building up to using steps 2 and 3, was to show all the sides are congruent. Okay. Now remember using cupcake, because now we want to kind of get it back to the angle part, because that's actually what we're trying to prove. We can say that angle BAD is congruent to angle DCB. Okay, so in my figure, here's BAD, here's DCB, and we can say that those are congruent because of cupcake, CPCTC, corresponding parts of congruent triangles are congruent. So we're able to say that. So I've got the first part of this done, kind of put a little check mark there. Now what I don't have done, I don't have the other one, which is angle ABC and CDA. I don't have those done. So I'm going to have to go back, kind of, let's get to, maybe let's draw two separate triangles here with that AC diagonal. I just need to give you a visual. That's why I'm doing this. If you're like, hey, I got this, I don't need your help, that's fine. Just go on ahead. But now I'm going to do the other diagonal. We still know that AB and CD are congruent. BC and AD are congruent. So this is two separate triangles formed by the other diagonal. So then I want to get in here and go, well, I know that AC is congruent to itself because of the reflexive property. So now I've got two new sets of triangles that are congruent. I now can say, okay, triangle ABC is congruent to CDA. And the reason, same reason as before, right? The other triangle, because of side, side, side. Now that would come from steps 2 and 6 in this particular case, okay? And then last step, I'll have to come over here, because remember we're trying to prove ABC, which is this angle right here, is congruent to CDA. Because I've already proven that the two triangles are congruent, then I can say angle ABC is congruent to angle CDA because of cupcake, CPCTC, because I proved those two triangles congruent. So lots of pure logic there, okay, to try and get that solved, but that's what happened there, okay? Now this one's a little bit shorter in letter B, okay? When you do your two-column proof, let me kind of get you going here. We're going to get started with, we already know that GHJN and JKLM are parallelograms. Okay, let's move our reasons over here. And that's given. Okay, got that. So we took care of that. I'm not going to worry about the collinear thing. That's not going to really help me solve anything. Okay? Now, we're trying to prove that ultimately G and L, those angles, are congruent to each other. Okay? So that's fine. We can do that. Let me kind of get you structured here as far as where to go. What do we know is true about angles? We learned two theorems about the angles of parallelograms. Okay? And we know that opposite angles in a parallelogram are going to be congruent to each other. That was the second one we learned. So we really don't need to worry about H or N or K and M. Don't worry about those. Focus on the G, this middle angle that's here, and then L. That's what we're really worried about, are those four angles, okay? So kind of bouncing off the fact that GHJN is a parallelogram, JKLM is a parallelogram, then we can get in here and say, well, angle HGN or HJN, angle HJN is congruent to angle G in that first parallelogram on the left. And then MJK, angle MJK, is congruent to angle L in the second parallelogram on the right. And the reason is because in a parallelogram, opposite angles are congruent. That's that second theorem that we just proved in example 4a, believe it or not. Okay? So we proved that these are equal and then these are equal here. That's what we did in the second step. So then step 3, this is going to be a real short one. Step 3, we can go, well, hey, the interesting thing is that HJN has to be congruent to angle MJK because they are vertical angles. And they are. So now these two are equal. Okay? So the middle two are equal, which means now we're ready to say that angle G has to be congruent to angle L. And the reason, because we proved that all of them are equal to each other, the reason is really simple. Remember, if you've got this, two things are set equal, like we have in step 2, HJN is congruent to G, and MJK is congruent to L. HJN and MJK are congruent to each other, so that means whatever's left over, they have to be equal to each other. That's very simply the transitive property. That's what happened there. Okay? So basically, if 1 is equal to 2 and 2 is equal to 3, then 1 has to be equal to 3. That's what's going on there. That's the transitive that we're talking about. Okay? So, woo, that'll get your mind swirling. All right, if you have questions, let's talk about it because we're definitely going to practice this in class tomorrow. So bring your questions.